Um, so hello, my name is Itai, and I'll be presenting the Google Visualization API, which is our API in order to make it easier to visualize your data. After some short background, I'll discuss the visualizations themselves, the structure of the tables of the data that you pass them in order to visualize, how you create a visualization and draw it on your web page. Later on, I'll talk about events that I use to communicate between the web page and the visualizations, and also between two or more visualizations on the same page. New features that we'll also cover are formatters and views. And later on, I'll talk about data connection, how to get the data not on the web page directly, but read it from servers, and then about our query API and language. I'll talk in a few minutes about the difference between JavaScript embedded native code and gadget wrapping. So you can wrap your visualization as gadgets, the advantages and disadvantages of this. And a few minutes in the end also about how and why to write your own visualization, or why to wrap it in our API instead of just having it as a standalone visualization. And in the end, we'll see a simple example using it all. And of course, questions. So note before I start, then it's going to be a quite techy talk, and there are many JavaScript examples, or at least snippets, and we're also going view source in a couple of times. You don't have to remember them, of course, or anything like this. It's all on our documentation site. I'll show at the end the exact URL, but you also don't need to remember it. I'll only go Google for Google visualization, and there you go. Everything is there. Okay. So the background is, before we start even with background, the concept is that structured data, raw data, is there. All of us are working it. Developers, many applications are about displaying this data. And you can't just show table of millions of rows. You have to visualize it in some way. So there are some generic charts, like pie chart or line chart, that everybody is using for all purposes. And there are some specific visualization, like thermometer, which is used, as far as I know, only to measure temperatures. In addition, there are another dimension is how easy to implement or to use visualization. It might be very easy, like in the case of a table. And you might also know this one. It's Gapminder's motion chart, moving bubbles, however you call it. It's a company that Google acquired about a year ago, and it can be used to tell stories or charts of about 5 dimensions. So this is a bit harder. So as we see, there are many options to visualize your data. We can see an example here. So this is just an iGoogle page, which is a dashboard combining from all 6 different visualizations. Each one of them is connected to a different data source, getting the data from. So the problem that we are facing as web developers that want to visualize our data is this. There are many visualizations. You need to select one of them. There are many data sources. Each one of them is JDBC, one of them is CSV file, one of them is, I don't know, spreadsheets, SQL, whatever. And you want to embed some of them in your blog. You want to embed some of them in a web page and some of them in Gadget in iGoogle. So there is a lot of mess there, and you have to do, every time you want to do something, you have to find the exact solution for now. And if you want to do something a bit different later on, then it's a problem. Or if you want to replace it later on, then it's a lot of work. And this is what we had in mind when we started to develop this API. So we said, okay, let's have a single platform or a single place that people can just go to, look for visualizations, knowing that everything on there is using the same API or trying to use the same API. And you can just take any visualization there and use it in a single API that you already know it on your web page or on your gadgets or on whenever you want to use it on the web. So we didn't want it to be only for Google visualizations, but to have it like an open platform that everybody can use and contribute and whatever. We also have directories that you can select from, not showing only ours. So let's take a look at this example. You know this page, it's Google Finance. And one of the nice things about this application is this chart that is, for a long time, was only used here. And what we did is actually we took it and wrapped it as in our API. It wasn't a lot of effort, so we just had to take it and wrap it to make it work with our API. And then you can see here a very simple, I wouldn't call it application, of course, but it's like I can just use it to my data. I change the data. And if I look at the code here, you can see that I just build the data, and within a few lines of code down here, I just use this nice visualization in my site. So this is what it's all about. So we said, okay, we are web developers. We know how to do it. Let's make it easy for us. So this is what I explained before. And in addition, so we are working at Google. We can use Google infrastructure to make this better for everyone. And this is what we wanted to do. Again, we wanted it to be open, and we wanted it to be JavaScript-based because most of the web developers know JavaScript. Again, by the way, this doesn't mean that all of the visualizations have to be written in JavaScript. In fact, the one that we just saw is Flash-based. But you just have to wrap it with JavaScript API so it can be used by any web page. Oops, sorry. So the common things to all visualizations are these. They have data that you want to present, and I'll talk in a minute about the data structure that we selected. They have options. Some of them don't have options, but most of them might have some options that you can configure them. For example, if you want a pie chart to be a 3D or not, where you want the labels, and so on. Of course, you can use defaults, but most of the visualizations have some options that you want to be able to configure. And the last thing that you want to tell the visualization where you want to put it. Like, for example, in a very similar to image. Okay, so you need to give it a div or span or some DOM element you want it to be presented in. So let's take a look at some snippets of code of how this is done. The first bold line is you have to load is the loader itself. So this is the general loader of Google that is used to load all of the Ajax APIs. It's used for search API, for maps, for many, many more. And what it does is a very light component that you load, and usually it's cached. So you don't wait for this or something. And this gives you two important methods. One of them is Google Load, to which one you say, okay, I want to load now the visualization API, version 1, which is the default. And on the top example, we see that we want also to load specific packages, specific visualizations of pie chart, which is one of the visualizations that we provide. Then the next thing we do is we set on load callback. So this is a function to be called once this is loaded. The Google Load, by the way, is the nice thing about it. Instead of just loading it from your web page directly, is that it deals with versions and caching very well. So you always get as fast as possible and the right version. On the example at the bottom, we see that we do quite the same, but the visualization itself is a pile of money in this case. Is not Google visualization, but it meets the standard that we set. So you load it externally from its URL. You still use Google Load to load the core API. Okay, so you get the data model and everything else. So as for the data, we thought about it for a while, and we said, okay, every visualization has its own data structure that it needs. There are some of them want it hierarchical, like XML. Some of them want it at like a network, so it's a bit different. But then we came up to the conclusion that most of the visualizations can deal quite well with two-dimensional table. So it's like a SQL table or whatever. We have as many rows as we want, and we have a set of columns. Each one of them has type, and might have, most of the time, will have ID and label to be displayed when appropriate, when needed. And each cell of this table has a value that its type depends on the value of the column. Okay, so if you have a column from type date, all of the values will be dates, JavaScript dates. And each column might have a formatted value, which is a text string that if, for example, we display the table, so we want to show. It's optional. And the same goes for properties, which I will not cover here, but are also possible. So the data types, again, the very basic data types, we didn't get into email addresses or I don't know, URLs or stuff like this. It's just string, number, Boolean, and some dates options. What you're doing is you are creating a new, after you loaded the API, you can just create a new data table and then add columns. Again, each one of them getting a type and optionally an ID and a name. And then you add rows and set values. Quite simple, actually. Now, once you have loaded the visualization that you want and you have the data table, all you have to do is to create the visualization once, and then you might draw it many times, each time with different data on if the data changes. So I would call it API, but you don't have to follow this. But in the concept, usually we try to work in the following way. So the constructor of the visualization should get only one parameter, which is the container, the place where you want to show it. And then when you draw it, when you actually draw it, you pass also the data that you want to draw and options that might change from time to time, as we see in this example. So let's take a look on our live example again. We have this very simple page with two charts. One of them is the bar chart. It's our nice, this is from our library. The second one is quite the same, but column chart. You see both of them have this nice feature that they move when you click on them. So if you look at the code, that's it. Most of it is just populate the data table with rows, of course, which is kind of a template stuff. But the real code for creating and visualizing the data is a few lines of code, which is quite nice. Any questions so far, by the way? There will be time at the end, but if you have anything urgent or so, just let me know. Yeah. So the next thing that we added to this API was events. We said, okay, many of the times that we see that people using visualizations is they don't want just to visualize it, but to have some interaction model. And this is specifically correct when you have dashboards. So maybe you want to have many data visualizations that are connected in a way that if you change one of them, you want the other to react. So the model that we chose was very similar to browser events because everybody knows it and it's quite effective. You just add a listener to event. You specify the visualization that you want to listen to, the kind of the event, and the function to be called when this event is triggered. So as we can see in this example, at the lines at the bottom, we have here two visualizations. One of them is of just a simple table, and the other of org chart. I'll show. Actually, I'll go now and show it. So we have this one. We have two visualizations. One of them is a simple table, and the other is org chart. Both of them are from our gallery. But the nice thing is that if you click on this one, so the event that is triggered is activating a function that sets the selection on the other one, and actually vice versa. So if you click on this one, you see the selection on the table is set. And the code, as you can see, it's just one line to say, okay, this is the visualization I want, this is the type of event, and the function to be called. Each visualization might provide different events. We have some general one called selection because it's really generic one, so we set some name convention. But each visualization might support or not support any type, and we try to keep it all in the documentation so you know actually what you can do. Yeah, so just showed it. Another thing is formatters. Formatters can be used to change the formatted value of all of the values in a single column. So we have some examples of that we already support, and there will be more. We are working on it. They are very useful in the table visualizations that we already saw, and you can see down here. So instead of like having just the raw data, so we present 5 as a number, you can also set it to show some nice arrow, or in this example here, it can be some bar. And we have some other formatters to format numbers, with how many digits you want after point and so on, or if you want comma instead of decimal point. So these are very easy to do. The important thing about it is to understand that they change the actual formatted values on the table. So if you have more than one visualization using the same table, the same data table, it might be a bit tricky, but it's important to understand it. Another new addition is the views. So you might know views from SQL, from SQL. Views let you have a kind of projection on a data table. So instead of having a data table, if you need, for example, to show a few visualizations that need to show the same data, but not exactly the same format of columns needed for each one of them, then you might want to use the data views, because you can specify in the data view which columns of the underlying table you want to have in this view. And if you have, a good example will be a pie chart that every time you use it, it needs only 2 columns, one for the label and one for the values. But all the same, you might want to show the same data in a table that you might have more columns that you want to show. And in this case, what you're doing is just, like in the example here, you're creating a view based on the same data table, but only selecting the columns that you want to show. By the way, one important thing is that all of the column and row, all of the indexes, all of the numbers starting from 0 and not from 1, this is nothing new for developers, just to make sure that everybody is aware of this. Unfortunately, I might say, but that's how it is. So the nice thing, of course, is that all of the visualizations, they can get us the parameter of the data, not only data table, but also data view. They are not aware that this is a data view. They share the same API, if you will. So this is a table visualization. I can draw it with a data table here, or I can draw it with a data view here. Okay, it doesn't know that this is a view. Just assume that it's a data table and present it all the same. The code is just similar to what you see here. So let's talk a bit about gadgets, unless there are any questions so far. Yeah. I'm sorry? So at the moment, no, you cannot use it when you're offline. You have to load it every time from the server. So the current answer is no, but the one thing I can tell you is that we hear this question a lot. So we are trying to figure out how to respond to this request, but the current answer is not. So as for gadgets, you can take the visualization as a JavaScript code and embed it in any web page, almost any web page actually, because some containers, some frameworks of a web page do not support just adding JavaScript code in them. But most of the times you can do it. The advantage of using gadgets is, you all know gadgets, I suppose, right? Anyone doesn't know gadgets? Yeah, okay. So the nice thing about them is that they're isolated, they're used in iframes, they're not risky, and you know exactly what's going on in them. You can share them with other people and all of the good stuff from gadgets, so you can use it on our visualization as well. So for all of our visualization, we have a very thin and simple wrapper as a gadget. So the one thing that you lose is that in some cases you can't configure them as nice as you can in native JavaScript, because in gadgets, so the ways to configure stuff are through perfs, and perfs are not that flexible, so they have to be like a list of stuff or input field. You can't just pass their, I don't know, array of colors or objects or stuff like this. But the advantage is, as we saw, that you can link them to an external data source, and then you can create a dashboard used by everybody, and you can just send them on to your friends or your colleagues and stuff like this. We saw the first example here was a dashboard made of our gadgets wrapping the visualizations. So this is a list of part of the visualizations that we already have. We have all of these simple charts that we saw. Some of them, we have the time series chart, which is actually the one used in finance. We have the org chart. We have a few gauges that you can use, widely used actually by many, many users. We have a few kinds of tables. We have the motion charts, the bubbles that we saw. We have some kinds of maps, a heat map, and actually more. And the nice thing about them is that all of them, I mean, almost none of them was written specially for this API. All of them were used by other products in Google within the organization, or in some products, external facing or not external facing. But all we had to do is take them, wrap them in this API, wrap this in a gadget, and there you go. And now it can be used and actually used by many developers, many web pages in the world, which is very much like what Chris said in the keynote, that we want to share, we want to let people using the stuff that we have and make the web nicer in this case, and very much easier for developer. So let's see what it takes in order to write your own visualization or to wrap a visualization in this API. I already talked about why you should do it, or I think it's quite obvious why you want to do it. If you have a visualization, why should it fit this to this standard? But just to add to the obvious reasons, so there are a few companies that wrote gadgets and visualizations that have two modes. One is a simple mode, and one is premium mode. They take money for the premium mode, and you can find the gadgets in our gallery. But if you want, the advanced features, you just have to pay. And I think they're doing quite well with this. So you might even get money from it. So all you have to do really is to have a constructor for this visualization, getting a container. And then you have to provide a draw function, getting the data and some options that you might have or might not have. If you want, you can also support events, but you don't have to. If it makes sense in a visualization to have events, then all you have to do is to say, okay, on click in this case, as we see in this example, I just trigger an event. So you just call the visualization event trigger function with this as the visualization and the name of the event that you want to trigger. It's for anybody else to catch it if they want and to do whatever they want. Let's see an example, a very nice example indeed. This lovely visualization is, in fact, just a table of cells with purple boxes around them. Looking at the code, you don't really expect it to be very sophisticated. So all that we have here is a constructor that's keeping the container. And then when you draw, this is the top lines now, on the draw function, we just iterate on the data tables that we received, iterating on the rows, then on the columns. And for each cell, we take the formatted value and wrap it with a TD, with a purple box around it, of course. And that's it. All of the things that you see from this point and below is not anymore about the visualization, but about the page that show this visualization in this case. So we just load the visualization itself. We load the API. We don't have to load the visualization because it's written in this page. We create the data and we display the visualization, myviz, with this data. Quite simple. This slide is about how to wrap your visualization, or actually any visualization, in a gadget. So we have some methods that we provide in the core API that you can use. Can be used to wrap your visualization in a gadget. One of them is called the gadget helper. It lets you create a query based on the prefs of the gadget. Usually, we take a pref called data source URL, which is the URL from which we want to read the data. And I'll get to it in a few minutes about how to read the data instead of writing it on the JavaScript code. Then you can use the same object to validate the response. And if the response is well, you can just read the data from it and work with it as if you created it on the JavaScript itself. If you already did it, then you can send it along to us. Make sure that you have a specific namespace. Create some documentation based on the template that we have, if you want. And if everything is okay, then we can just publish it on our documentation. And there you go. People might be able just to use it, and it's nice. So as I said, there is on all of the examples that we saw so far, the data table was created on the client, on the JavaScript. So it means that you must have the data somewhere. So maybe you render the page knowing already what the data is. But this is not the case in many places. Many times we know that we have the data maybe on server, and we don't want to render the page with all of these lines of add cell. And for this thing, we created an API for the data sources as well. since there are many types of them, we want to create a single layer that can create, at the moment what it is a JSON format that lets you create a data table on the client based on this JSON. So you can create this JSON on the server side and pass it, and then you don't have to deal with creating all of this JavaScript code on the client side. So this is what this API is about. Currently, it's not open yet, so the only way that you can use it is Google Spreadsheets. You can read directly data from Google Spreadsheets using this mechanism that I'll show, and even manipulate it, and you don't have to worry about creating this data on the client side. We are working on opening it, and once this is done, so we hope that many data sources will also support this API, and then any of the visualizations that use our API will be able to read the data from a variety of data sources and present it very easily. The way it is done is as follows. You just create a new query object, give it a URL of the, again, currently the URL should be of the Google Spreadsheet page. Then you can set a query on top of it. So maybe you don't want the exact structure of the table on the database, on the spreadsheet, but you can also select some columns from it and group them and order them. If you know SQL, it's quite similar. Then you send the query and set a callback function to be called once the query is back. And from the response, you can just get the data and you're set.
Question?
Yeah, sure.
Must the data source be in the internet or can it be in your intranet? Because the data source which you will access, must it be in the internet available?
So it can be in your intranet because what happens is that the browser just send a request to this URL. Okay, so if the browser is in your VPN, for example, and the URL is something that is unknown outside, but is known to your browser at the moment, then it will work.
So it's just running on the client side, right?
Yeah, yeah. Yeah, it doesn't go to Google servers or anything like this. You specify the URL and the browser goes directly to this URL. So once we open this API and you will have, for example, you have some application that have some data in it, and you make this application a data source of this API, then your browser can be configured to get a visualization, a web page, or a gadget can send a query to this place. It doesn't go out of the VPN. It all remains in your stuff. Yeah?
It's going back to that question. Could you clarify if today can they take data from another source other than spreadsheet, or is it only available for spreadsheets today?
So,
So
the answer first is no. Yeah, of course. So the question was, are there any other data sources out of Google Spreadsheet that currently support this API? And if not, which is the answer, when it will be. So the only thing I can tell at the moment is that it will be soon. We are working on it, but I don't have any timelines yet.
Maybe another question into that. What other data sources are you planning to integrate? What are the major ones? And what type of data source?
So I'll explain in a minute about what we have today on the Google Spreadsheets, and I can't exactly tell what is our roadmap here, but we want our major goal is to let anyone use it. Okay, we just want to be easy. We want it to be as easy as possible to everyone that has data to change it to this format. And the format is quite simple, actually. So once we have all of the tools that we want to have out there, you should be able to take your, I don't know, say CSV files or your SQL data and whatever else and change it to this format. But we are not there yet. So it might take some time. Again, I can't tell timelines yet, but this is our goal. And in the example I'll show in a minute, so we'll be able to see how it works with Google Spreadsheet. So there is this query language, quite similar to SQL. You have select, from, where, group by, all of the things that you have in SQL. Not all of them, in fact, because there is a main difference that SQL is for data-oriented stuff, and we are here for visualizations. And that's why we left aside for the moment the really hard stuff of joins and subselects and very hard to implement and advanced feature of SQL. What we did add instead were things that related more to visualization, like labels and formats. Because in SQL you have raw data, you don't deal with formats. And in our case, it's more important to let the user also specify the format they want the data to be in, if they want to present it. Yeah. Could you repeat, please, with Mike, because I didn't hear?
How about security? I didn't see in the example key for access to the source of the spreadsheet. So anybody can access to the URL. Okay,
very good question. So about security, at the moment, the way it works with the spreadsheet, you have two modes. The spreadsheet might be a public one, okay, because you can publish your spreadsheet, and then it means that nobody needs any credential to access them. Okay, so you just you provide as the URL the public version of the spreadsheet, and then nobody needs anything to access it. If you do want it to be private, and you can provide the URL of the live data, okay, of the spreadsheet, and not of the published version. And this means that if someone tries to access it from this place, you'll get just a simple message saying you have to sign in, and this will be a link. You just click on it, you'll get you have to sign in on the page that opens up with this spreadsheet URL, and then you can just go back, refresh the page, and you'll see it. And this also might change a bit, but this is the concept. Yeah. So we do, of course, make sure that you are signed in, you have the right access to get to this URL. One word about this is that once we do open our API for data sources, it will be the responsible of the data source owner to make sure that the user is a valid user, okay? Because we can't provide it. It's not that there is any cycle going through our server or something like this. So if it's your MySQL URL, you have to make sure that the user is authenticated. This is an example for why we added the pivot clause in the query language, because in many cases you have the underlying table in a way that is not similar to the way that the visualization needs the data to be in. So each visualization, although we said that there is a single API, it's a two-dimensional table, each visualization requires the data to be a bit different. So this motion chart that we see here on the top needs the first column are the entities, so like one row for each bubble, and then you have one column to each dimensions, up to 5 of them. So if the original table is the way that we see on the left side, you have to pivot it in order to get it to work with this visualization. Right? And again, as I said, we want to open it, we want to provide it and make as many data sources as possible. So any question before I go to complete example of all of these things? Yeah. I'm not sure I understand.
The query language is made for visualizing just a subset of the data source.
Okay.
But if the query language is running on the client side, it should be quite easily to modify. Like, I can select another customer, for instance. So,
I'm not sure that I understand.
I'm sorry. So, for instance, if my query want to visualize data from a customer, and this query is running from the client side, I could just change the customer in the query. Am I right?
Yeah, so for example, what you can specify is in the where clause, just saying, okay, I want to read this data source where customer equals something. Okay.
And this query is on the client side.
No, okay. No, it's processed on the server side.
Okay.
So we have a library that, again, is only implemented in Google Spreadsheet that instead of bringing the whole data to the client side and then filter it on the server side. Okay. That's the whole point.
Okay.
So because many times you have a very large data source, you don't want to bring all of the data to the client side and then to sort it or to filter it or whatever. So this is all done on the server side.
Okay, thanks.
Yeah.
So can I use SSL connections when I query the data?
Yeah, you can use SSL, of course. So let me just go to the last example because I don't know how we are with time, but let's take a look on this example. It's quite just a few minutes and then we'll have time for Q&A. So this is what we want to achieve. There is this fictional cinematics company. They have branches all over Europe, and they want to have a web page that looks something like this. They have the title, of course, on the top, and then they have a map of all of the cinemas and the table of all of the cinemas that are connected to each other. So when you select in the table, you see this is the same place is selected on the map, and vice versa. They want the table because in the table they might have details that are not shown on the map. And on the other end, they want the map because you want to look for the one that is nearest to your home or something like this. These are static data. But on the bottom of the page, they want to show you the live data of their selling tickets because people want to see movies that everybody else seeing because they think it's a good movie. So they prepare this spreadsheet. This spreadsheet has the locations of the theaters and one row for each movie, which they update every time that they sell a ticket. And again, they want the chart at the bottom to take the data from there. I'll just show the web page so we can see it now. So here you see there is this map here. And the location, we only have 3 locations at the moment. This is a very young chain. Here you can see that there is this food, if food is allowed in the theater or not. And when you click on it, you just see the map. When you click on the map, the same row is selected on the table, so they are connected. And on the bottom, you can see the data from the spreadsheet that we saw a moment ago. Here, of course, you can click on it and all of the nice things that you have from this visualization. Okay? So this is the page. Let's look at the code. So the first thing we do, we're loading the visualization itself, the API itself, and the table, map, and column bars, which are the visualizations that are used here. We set a callback to be called once everything is loaded. Then in this function, we create a query object. We set this query to be sent to the spreadsheet, and once it is back, so this is the function that we specify here at the bottom. We say, okay, send the query, and once it's back, call the callback method called draw. Once draw is called, this means that we have the response on the client side. We have the data table. We check if there is an error. We just do something. In this case, it's just alert that there was an error. But of course, you can do better things. We get the data table from the response and create a chart based on this data table. This time we said that we want it to be stacked, as we saw in the example, and we want the legend to be at the bottom. Next thing that we do is create the static data at the top. We create a geodata table with the city name and if food is allowed. We added 3 rows in this example. And the thing that you see at the bottom is important, and create a view with only 2 columns to be used by the map, because the map doesn't know how to deal with the food column. And that's it. We are set. We create the table and the map. And the last thing we do here is we add listeners between the map and the table to be called when we select row in each one of them. And that's it. So if we look at the actual code here, you can see that it wasn't a snippet. It was about the whole code. Okay. This is it. Okay, so that's it. Before the Q&A, I'll just go back again. We discussed the visualization itself, the way that they get data in the data table, how you create and draw them, events, formatters, and views to be used to make it even more robust. The data connection, that you can get the data instead of creating it on the JavaScript side. You can get it from some servers that support it. The difference between native JavaScript and gadgets, and how to create your own and submit it to our directory. And again, all of this information and much more, including references, examples, and a live group that people asking questions and answering each other, and sometimes you also pop in and answering. You just type Google and visualization on any search engine around. Okay? Questions? Yeah.
The way you're loading the data URL is in blocking mode, which means it's synchronous, and you return as soon as the data is loaded, which means that the browser is blocking at that time. Are you going to provide a method to asynchronously load data, or is
no, could you repeat, please? I didn't.
The thing is, you're calling data.load whatever, and you pass a data URL. And the next step would be to call the visualization's draw method, which means that the browser blocks until the data is actually loaded. Is that correct?
No, that's not correct. This is because when you I'll go back to the example here. So you see the last line here. This is the query.send, and you provide a method to be called when the response is back. So this is asynchronous call. Okay? Okay? Yeah. So could you wait just a second until the mic is getting there? Everybody will hear you.
In the gadget section, you talked about a gadget helper object. Mm-hmm. Okay. Is that only specific for Google gadgets, or will it be available for non-Google platforms also?
No, so this is for Google Gadget only. But the important thing to mention here is that you can write a gadget around any visualization, not only the current gadget. So if you want to take some visualization and wrap it with your own gadget because you want it to be attached to some other data source, you can do it. So wrapping in gadgets is something nice, but to your point, then no. I mean, it's only for Google Gadgets. Yeah, there is someone out there.
I'm not sure if it's a general Ajax question, but is it possible to stream data? So, for example, on progress callback function. So, for example, I'm a data source and I'm giving you the current time every second, and I want to display it in a continuous plot. Is it possible to do this?
So I'm not sure I got the... You can set a query every time you want, and actually in the query there is something called refresh interval that you can set the query with the refresh interval for 1 second, for example, and then once the response is getting back, it will be automatically...
Once the complete response is going back. So I'm not sure if it's a general Ajax question. So to work on data that it's not finished while transmitting. So for example, when I have a stream, so I start sending data to the client and start and
I see what you asked.
And on progress, I'm redrawing the visualization.
No, so you just have to redraw it. So every time that you get, so there is no incremental data getting or something like this. You just have to wait for the data, all of the data arrives, and then we build the data model, the data table, and then you visualize it. So there is no kind of incremental query mechanism at the moment.
Does anyone know if this is possible with Ajax, or?
I don't think it's an Ajax question. In Ajax you can do such things, but if in our case, then...
I think it is an Ajax question. There's something called Comet-D, which does synchronously streaming, but it's more of a hack. It's long-lived HTTP connections which don't get closed on sending the request or getting the response. So you're able to constantly send data to the server and receive data from the server back within one continuous stream. And when the timeout comes after some seconds, let it be 10 seconds or something, another request is made.
Okay.
When I use the maps, the Google map within the visualization API, do I have the same controls over the map like I have with the Maps API?
What types of controls?
No, yeah, you could.
So you can
just controls, switch to Earth, or have markers, info windows.
No, so this is
and I don't know, draw on the map, or can I only display the data from my data tables?
This is the code here. You see, map equals new Google visualization map. You get a container, and that's it. The only option here is show tip true, but you could even not specify this one. You just don't have to do anything. It's all fall to defaults.
I'm not sure you didn't understand me. You have the map there. You can visualize data that you have from a table, from your SQL or from your Google spreadsheet. But can you also manipulate the map as well within this API call for the visualization API, or do I have to also call the API for the maps to have more functions within there?
So,
like drawing a polygon, like opening more info windows, like putting something in there.
So we don't have all of the Maps API features in this visualization. We do have some of them, and we'll extend it with time. But so far, you don't have all of these options that you can do with Map in this one.
I've got a question where the data is going. Does it depend on the visualization I choose? So, if I have to send data to a server to get a GIF back, or
I didn't hear the first words.
Yeah, I'm wondering if I have to send data to some servers to get a fancy diff or GIF back, or some customized Flash, or is the rendering going on the client, or does it depend on the widget I'm choosing?
Very good question. So We hear it a lot about security, right? So people say, okay, I have this data, but is it remaining on the client, on my browser, or does it go somewhere else? This depends on the visualization itself. The examples that we saw here, most of them are Flash-based and vector graphics-based. So it all happens on your browser. The Flash or the code is brought from Google or from third party, but there is nothing goes out with your data. This is not always the case, though, because, for example, we have, I don't know if you know the Charts API of Google. So this is something that generates images, PNG files from your data. It means that we take the data, we create a URL, and we go to Google servers, and we don't keep this information, but still, it means that it's sent out of your browser. The important thing to understand, it depends on the specific visualization, okay? And we do have wrappers, by the way, to this kind of thing, which is nice, but you have to be aware of this, yeah. We write it in the policy in our documentation of each visualization, what it does with the data. Most of them just don't go out of the browser.
And do you make a copy of the visualization? And so when I submit a visualization as a developer and provide the hosting or the JavaScript code and so on, so do you copy it when I submit it? And make some kind of version control and no?
No, we don't actually host it. We just point it from our directory.
So when people get used to use it, then I change the code as a developer and say, okay, send me every data to my evil website, and so it's a security.
Okay, I understand what you say. So again, this is a policy. In our directory, this is something we thought about a lot. So we do want to provide data about third parties, okay? We don't host them. We just specify them in our directory. We make sure that there is a big disclaimer that this is a third-party stuff, okay? Using third-party codes in your web browser or in your application is in a way risky, yeah. And we can't even look at the code because you can change it anytime. So the answer is that using a third party is a risk if you don't know them, if you don't trust them, then just don't do it. We have a big disclaimer in our directories that this is the third party.
I've got another question regarding browser versions. The pain of IE6, is it supported or does it depend on the visualization? Do you have a fallback? So,
IE6 is supported by, I think, all of our visualizations.
Oh, yeah, nice.
Yeah. Anyone else?
You mentioned labels and formatters within the query language. Could you give an example what these formatters exactly do?
So label means that you can specify for a specific column. Maybe you have data that is doesn't have any label inside of it, but you want it, when you get it back, you want it to be labeled already. So you can specify for each column ID on the label. Again, there are examples on our codes. I don't want to get into it now, but you can specify for each column ID what label you want it to be called. And the same goes for formatters. Only in formatters you specify a pattern. So if it's a number, it's like the pound sign and comma and stuff like this, and then all of the data coming back from a table that might not have formatted data is already formatted in this way.
You show an example where the SQL statement is built on the client side. So I wonder what I can do to prevent SQL injections.
I'm not sure I understand.
On the SQL statement is built on the client side. Show an example a few pages ago. And
so the language, the SQL, is not on the client side.
Not? Okay.
It's processed on the server side, on the data source. In this case, on the Google spreadsheet side, on the server. So if you, for example, have a very large spreadsheet with many, many rows, and you want to visualize only, let's say, I don't know, rows that fit some criteria, then you can specify on the URL of the spreadsheet to add something called TQ equals where, I don't know, salary greater than 10,000, and then you only get on the data table to the client side the rows that fits this filter. So it doesn't happen on the client side, it happens on the server side.
Okay, but anybody can change the URL to get other data.
That's correct. That's correct. It doesn't mean that there is no access to this whole data from the browser. Yeah. So it means that if you open a public spreadsheet, and so you can't control the access to limit the access only for the selected rows. That's correct.
Okay, thanks.
Okay. One more. What's it?
I have a question regarding the views you mentioned. How is it possible for me as an external developer to implement my own view?
Of course. I mean, views are something that you do on the clients on your web page. You get a data table and then you just create a view, just like we see here.
And if I have an own view, how is the process of selecting or projecting the data that I want to have displayed? Am I called for each row your library processes, or have I to prepare all the data at once and publish it to your library?
I didn't understand.
So let's say we have a database that is huger than I wanted. And for this purpose, I need a view to get rid of some columns. Do I have to remove, do I have to provide the whole data set at once, the whole result? Or
Yeah, so
am I called incrementally?
No, so view is only about removing columns at the moment. So yeah, you must have the data table completely, and then you just create a new view projection based on it.
Okay.
Okay, I suggest that we finish now, and just if you have any more questions, you can come here. Thank you very much.